Hey everybody, Mrs. Bianchi. We're looking at number 10 on area of triangles. It says a triangular flag has an area of 187.5 square inches. The base of the flag measures 25 inches. How tall is the triangular flag? So since they're telling you it's a triangular flag and we're talking about area, which we see here, then you know you're going to be using this formula, which is the area formula for area of a triangle. It's area equals half times the base times the height. So the next step is to substitute in the values that are known, which this is one of the known values, and you have to know what letter to put it underneath. Since they're telling you it's the area, this value right here goes underneath the A. So that, again, is 187 and 5 tenths. We'll bring down the constant, which is a half. Now they tell you that the base of the flag measures 25. So underneath the B, we're going to put that number 25. What we don't know is the height. How tall is the triangular flag? That's the same thing as asking the height of it. So we'll bring down that variable h because that's what we're looking for. All right, so the next step is to simplify this. We have to find what half of 25 is. So to speed things up, we're going to use a calculator, but make sure you're writing all these things down on your piece of paper. So we talked about two ways that you can find half of 25. The easiest way, which has the fewest buttons needed to be pressed on a calculator, is to put the whole number in first, which is 25, and taking half of something is the same as dividing it by 2, and we get 12.5. So let's write that number down. But I do want to show you another way in the event that you get mixed up. If you ever get mixed up, I want to remind you that a half is equal to 5 tenths. A half is equal to 5 tenths. So if you wanted to replace this with its decimal equivalent and just multiply this value times this value, you would still get 12 and 5 tenths. So just to make sure you understand that that's true, let's actually show you that. So I'm going to put in the 0 and 5 tenths times the 25, and you see I get the same thing. All right, but let's put the calculator away and let's bring everything down. Let's bring the h down, and let's bring the 187 and 5 tenths down. And the equal sign. All right, so the next step is to recognize that we still have an algebra problem here, and we have to apply our inverse operations. Now I want to go back to something that we talked about in class, and that's that idea of thinking of a simpler problem. The one we did in class looked like this. It was 12 equals 3 times 4. And what we asked ourselves is, what if we didn't know this value? Pretend you don't know that. What would you have to do with these two numbers to get 4? And in class, many of you knew that we would have to divide 12 divided by 3 to get 4. Well, likewise, if we didn't know this number, pretend you don't know that's a 3. What would you have to do with the 12 and the 4 to get 3? Same thing, right? You would have to do 12 divided by 4 to get 3. So wouldn't it make sense that in this case, that we'd be dividing these two numbers to get the missing number? So let me erase this so we didn't realize it has nothing to do with this problem. And let's talk about how do you represent that on your piece of paper, because you have to write all this on your paper. We show the inverse operation, which the opposite of multiply a variable by 12 and 5 tenths is to divide it by 12 and 5 tenths. So we write the 12 and 5 tenths on both sides of the equation to keep it what we call balanced. We are going to learn a lot more about that as the year goes on. All right, and now this would simplify. Anytime you have the same number on the numerator and the denominator are the same number, then it would divide out to be 1. But just in case you didn't understand that, let me show you that. So if I take 12 and 5 tenths and I divide that by 12 and 5 tenths, it equals 1. And 1 times h is h. So we'll show that by most people, what they do is they put a line through there to show that it equals 1. And then we bring down the h. All right, now this is not mental math for most folks, but let's make sure we understand how do you enter it into a calculator. Now, later on in the year, we're going to be reviewing how to do the algorithm for that, because you won't always be allowed to use a calculator. But for questions like this, you would be allowed to use a calculator. So when you enter it in the calculator, it's almost like you work your way down. You start at the top, you put this number in first. This fraction bar means divide, and then you put in this number. All right, so watch. 187 and 5 tenths, 187 5 tenths, divided by, that's what this symbol means, 12 and 5/10. So again, that's this number that we just put in the calculator. And then we hit equals, and we get this number. So the height is 15. And we have to talk about what's the unit on that, because would it be a straight line? Could it be represented with a piece of string? Or is it a number of tiles? Or is it a number of cubes? In class, we've talked a lot about how height would be represented with a piece of string, which is one dimension. So it's not square. It's just regular old inches. It's 15 inches, not square inches, not cubic inches.